is lesson 7-3. And we're not going to be working with polygons, we're going to more focus on triangles. And here we're going to be covering the lesson on similar triangles. What makes a similar triangle is 3 ways to prove triangles are similar is using the side similar triangles theorem. And here it states that if all 3 sides are proportional in a pair of triangles, then we can make the conclusion that the pair of triangles are similar. And here's the example here. So here I kind of already separated them apart. Here I separated the short leg, these are the lowest numbers out of these 3 numbers. 6 is the smallest number. Out of these 3 numbers, 9 is the smallest number. Or you can also just look at the diagram where 6 is the shortest side out of 3 sides of the triangle. Here 9 is the shortest side out of the 3 sides of the triangle. So here what I'm going to do is to determine if they are triangles are similar, we're going to write the ratio here. And the ratio we chose is, we're going to be using is small triangle over the large triangle. Okay, the first thing we're going to compare is the short leg. The value of the short leg of the small triangle is 6, and the value of the large triangle short leg is 9. Okay, and we're going to simplify that, and we can divide 6 and 9 with 3. 6 divided by 3 is 2, 9 divided by 3 is 3. Okay. And here the next one is, we're going to compare is the long side, which is 8 and 12. So here the long side of the small triangle is 8, and the value of the long side of the large triangle is 12. And here I can divide 8 and 12 by, you can divide by 2, but it'll take longer for you to simplify, so I just decided to divide by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. Okay. And the last one we're going to compare is, once again, it's from small, already shows so the same. We're going to do small triangle over large triangle. And here we're going to go to the longest side. Okay. Longest side is going to be, for this here, the longest side equals to 10. And here the longest side for the large triangle is 15. So here we can divide 10 and 15 by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. Okay. So here I can determine that all 3 sides are proportional. How? Using the scale factor. 2 over 3 is our scale factor. And here you can write it at 4 ways: 2 to 3, 3 over 2, or 2 to 3, or 3 to 2. And that's the first way to determine triangles are similar. Okay. Here, this is a statement I'm going to be using. Triangles, STU, is similar or proportionate to triangle VWX. Why? We're using the side, similar triangles theorem. Once again, with side, because we compared all 3 sides to determine that the 2 triangles are similar. Okay. That's the first example. Here we're going on to the next example. Is using the side angle side similar triangles theorem. And here the side angle side similar triangles theorem. What does it include? I'm just moving it down since we're not starting on with a lot of things we're going to be covering. Here is if there is a corresponding angles that are congruent and its rays are proportionate in a pair of triangles, then conclude a pair of triangles are proportionate. Okay, once again, we need a corresponding angles that are congruent, and we need the rays of the angles that needs to be proportionate in those pair of triangles. So here's an example here. So here we're given the 2 triangles here, or we're given a corresponding congruent angle here, and here are the connecting rays, right? Is the short leg and the long leg here are connecting to this angle here, the congruent angle. And here we're just going to determine if the short leg are going to be the other short leg is going to be proportionate to the long leg. If it's proportionate, then we can determine that these 2 triangles are proportionate. Once again, here the ratio we're going to be using it depends on you. This was we switch it up, right? What we're gonna be doing now is large triangle over small triangle. So here the values will be determined by what we're comparing. So here first we're gonna compare the long long legs or long sides of the both triangles. Here the value of the large triangle long leg is 16, and the value of the small triangle's long leg is 8. And here I can divide 16 and 8 by 8. 16 divided by 8 is 2. 8 divided by 8 is 1. The next one I'm going to compare is the short leg. Okay. The value of the large triangle's short leg is 12. And the value of the small triangle's long leg, long leg is, short leg is 6. The value of the large triangle's short leg is 12. The value of the small triangle's short leg is 6. And here I can divide 12 and 6 by 6. 12 divided by 6 is 2. 6 divided by 6 is 1. Okay. And here, you're looking at this here together, is you can see the scale factor. Here is going to be 2 over 1. So here the answer is 2 over 1, or 1 over 2, or 1 to 2, or 2 to 1. And here we can confirm that triangle 1 is proportionate to triangle number 2, because using the side angle side similar triangles theorem. Why is it the side angle side similar triangles theorem? It's just the angle here is congruent, and here the sides here, side 1 is proportionate, and side number 2 is also proportional. Okay, we can tell that both of them are proportional to each other. Let me rephrase that. Sorry. The long sides ratio is proportionate to the short legs ratios that we're comparing. The last one here we're going to be comparing is a lot easier than most. We're going to be using the angle similar triangles theorem. If there is two corresponding congruent angles in a pair of triangles, then the triangles are similar. For to determine if the angle are similar triangles theorem, we just need at least two corresponding angles in a pair of triangles to determine that the triangles are similar. So here, you already could see that angle A is equal to angle B, angle B is equal to angle E. Here it's kind of blue because just imagine this is going to be the third side. You don't need to be congruent, but you already know that's congruent. Why? Because when two angles are congruent, then you know that the third angle is already automatically congruent. So here, the side we're going to be covering is angle A is congruent to angle D, angle B is congruent to angle E, right? It's only two things you need, and right there you can determine that triangle ABC is proportionate to triangles DEF using what theorem? We're going to be using the theorem of the angle similar triangles theorem. Okay. And that's pretty much the lesson. Thank you.